go, here we 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 go. Here we go, here we go, here we go, here we go.
And good evening, good afternoon, good morning, wherever you may be in the world. My name is Meisado Casing. Welcome back to another episode of Containers on the Couch. And today we're going to be talking about Amazon ECS Solution Blueprints for Terraform. We have a number of amazing guests today. And we'll start. Arvind, would you like to please introduce yourself?
Absolutely. Thank you, Maish, and good afternoon, good morning, good evening, folks. My name is Arvind Soni. I lead our ECS Containers Specialist team. Happy to be here and talking about ECS Solution Blueprints.
Nathan, please.
Absolutely. Thanks, Maish. Hello, everybody. I'm Nathan Ness, Senior Container Specialist SA, focused on Amazon ECS and AWS Fargate. Thank you for having me today. Should be a lot of fun. Excited to take you through some of the examples.
Awesome. Jessica, please introduce yourself.
Hi, everyone. My name is Jessica Dean. I'm a principal developer advocate here for Elastic Container Services, and this is my first Containers from the Couch. So I'm very happy to be here. Granted, I am sitting in a chair, but I mean, couch chair, it's same thing, seated down. Very happy to talk about ECS and Blueprints and AWS today.
Thank you very much. And my name is Meisado Casing. I'm also a developer advocate. Jessica and I work together. And today we have an interesting topic for you. It's about Amazon Solution, ECS Solution Blueprints for Terraform. It's a bit of a mouthful. So do one of you want to kind of break that down, what that actually means for us?
Yeah, happy to. So just to give you guys a little bit of motivation behind, right? Like there's a lot of collateral already out there in terms of if you focus on as a new user, let's say a user is new to containers, they want to modernize and get all the benefits of containers, right? And they want to adopt ECS, they want to adopt ECS Fargate. There's still quite a bit of a learning curve because you have to understand CI/CD, you have to understand observability, security, and then you have to understand the ECS and Fargate constructs, right? So with the goal with the ECS Solution Blueprints is we want to help you get to the container benefits faster. And we want to do that in a way so that you can run your apps in your environment using infra as a code with all the things such as CI/CD, observability, security baked into it, right? So it's an end-to-end solution. It may not be a complete solution for your scenario, but it's a solid starting point. It's an end-to-end along with automation so that you can adopt containers faster. And we also want to bring in the learnings that we have in terms of people, process, and workflows that we see at other customers, right? So for example, there will be a core infrastructure team that will set up your networking fabric, the IAM, the account. There will be a DevOps team that can, probably do the CI/CD and the service templates, and there's the application team, right? So there are these kind of different personas. They may be a small team, they may be large teams, but the idea is to bring the solution with the people in mind and create those kind of blueprints that you can adopt and extend in your to serve your needs. But the top line goal is you want to make sure you get to container values faster rather than having to learn and spend several weeks. We want to enable you to run your apps in your environment in matter of hours.
I would also add, it's good, from a learning opportunity as well. Like if you want to, spin up these services and learn what's required, I find that there's no better way to learn than doing it in infrastructure as code because it defines, the properties. Documentation for Terraform is typically very good as far as what properties are required, what is it asking for? Is it asking for a string? Is it asking for a list or a Boolean? And, when you have all of those put together in what we have for the blueprints, you can use it as a learning tool as well around, what's required from an ECS perspective to run a load balance workload on Fargate.
Now, just a question for my own knowledge, because I am still like new to some of the stuff with AWS and ECS and even Blueprints. I can use Terraform with AWS in general. What's the use case for specifically why I'm using Terraform with Blueprints? Blueprints, it sounds like, is giving me this extra benefit. That's what's making it easier for me to get started, right? That's what's helping me set up the kind of blueprint of what infrastructure code might look like or what my ECS deployment might look like. And Terraform's just helping me facilitate that, or just want to drive some clarity there?
Yeah, so Terraform is one way of doing it. Like it's the infra as a code. Like with Terraform, you could provision databases, you can provision load balancers, right?
Right.
So here with Terraform, we are going to provision both sort of the core infrastructure, ECS clusters, VPCs, subnets, IAM roles. And also we will provision the service and the task definition and associated things that are needed for those tasks. Like, for example, if some task needs a DynamoDB, we can provision DynamoDB. If some task needs a load balancer, we'll provision an ALB. And we'll walk through some of those examples, and that will make it more clear how Terraform is the vehicle and sort of the Blueprints is the recipe that is riding. By the way, we'll also have the CDK-based blueprints coming out soon. That's also in the works. So Terraform, CDK, these are all essentially automation and infra as a code tools. The blueprints are the recipes and that bring the best practices and well-architected, our knowledge of the patterns coded into it.
Got it.
Yeah. I think we do make a lot of strong opinions around what the default should be, or strong defaults actually. And in Terraform, those are loosely held via variables file. If you want to change them, obviously everyone's customers' environments look pretty different, and so we can give a set of opinions. If you want to change them, you easily can via variable, most typically. And if the variable is not there, that's something that we're looking to continue to improve as well. If something needs to be parameterized, let's add that in and give the benefit to the mass of the customers.
Right.
Yep.
And I mean, I know this particular session is we're talking about blueprints with Terraform, but since Arvind, since you did mention that CDK is also coming, you also still have that same ability to override variables and parameters when you're using CDK or CloudFormation.
Absolutely. Yep.
Yeah. So it gives you really setting the customer up for that success where you're giving them that control. They can kind of play with that getting started environment and tweak it to however they see fit, depending on how their environment is.
Yeah, and let's take a quick look at it, right? So we'll on one hand, we'll follow the quick start. This is how I envision our customers benefiting from the blueprints, right? So if you just follow the quick start, and I'm going to git clone the repository here.
And this is publicly available on GitHub right now. Like people can
Absolutely.
go and fork it, and awesome.
Yep.
Cool.
So we'll go into Terraform, and I'm going to go into the core infrastructure. We'll start with this one, and I'm going to describe it in more details. Let me just fire it off here. What we recommend is that you copy the Terraform TFVARs examples file that we have into your own TFVARs. For people not familiar with Terraform, just think of it as this is the input file to this module where you are going to define the parameters, right? So I'm going to do that.
Like your availability zone or your region you want to do, the size of your instances, et cetera, et cetera.
Exactly. So in this case, let's say I want to change the region. I want to run it on US West 1, and I'm going to make it, give this a stack a new name.
And just a question right here, since we're seeing region, do these blueprints work in all AWS regions?
Yeah, they should, wherever there is ECS, wherever there is Fargate. These are currently using mostly the core services, so they should work in pretty much all the regions.
Awesome.
Okay, so we're going to do this, and we will do a Terraform init. So Terraform init, it essentially initializes the module. In this case, mostly the AWS provider modules, things like VPC and clusters and things like that. So it's just going to initialize it, and then we are going to just apply it. And I'm going to let that go. It takes about a few minutes for it to go ahead and provision the stuff. And meanwhile, I'll walk you through what it is doing since we went to the core infrastructure, right? So here is the example, and here's the core infrastructure. And these are all mostly simple right now. There are not submodules and stuff like that. It's pretty flat. There's a main.tf file, which has most of the stuff that we are creating, right, using Terraform. So for example, Mahesh highlighted that you could input things like availability zone. Now, most of the time, what we see when customers run containers is they will have a minimum of 3 AZs where they will deploy the task replicas. So there is a sensible default that, hey, we will create subnets, private and public subnets. We'll create one private subnet per AZ and one public subnet per AZ up to a maximum of 3. You can, of course, come in here and change it.
Right.
But if there are not three AZs, like in US West 1, there is only 2, we'll only do 2. So it's a minimum of either 3 or whatever is available. Okay. So some sensible defaults are coded in already. And they are set here. This part is just defining the local variables. We're going to use it in other places. Any questions so far?
No.
So there was one actual question which came in from the chat. The question was, is Terraform blueprints in is Terraform code in a best practice most commonly deployed template? Is that kind of accurate? That was a question from Ryu CS.
Sorry, didn't catch the question. What is the question?
The question is the blueprints from in this Terraform code is like the best practices most commonly deployed template? Is that what you would call it? Or
yeah, the attempt is really to put in all that we know of, like in terms of best practices, right? As I said, most of the customers, they will have 3 AZs. If you're deploying a load balance service, they will create 3 instances, three replicas, so that one replica lands on each of the AZ. That Fargate will distribute it for you. So that knowledge and that pattern we have, we are aware of it, right? And so we are like, yeah, I mean, that's a sensible starting point. And you will see that in many places. Like a great example is the tags. Tags are this silent, benign thing, but they're super valuable, especially when you're looking at cost distribution in the cost explorer and stuff like that, right? So we have tags over here, and you can, of course, bring in your own tags like cost center and team name and stuff like that. But the idea is to get you started in the right direction, and with all the best practices that we know of. And we'll continue to enhance it. It's probably not complete. It doesn't include all the best practices now, but that's the aspiration.
It sounds like it's like best practices when you're getting started kind of thing. And then everything can evolve from there depending on what your environment needs, what your situation is for your application and your infra.
Absolutely. Look, this is also another example, right? Task execution role in ECS is the role that the ECS agent uses. The ECS agent that is running in the container host or in Fargate uses to fetch the image, uses to fetch the parameter from SSM. So if you need, most of the time, customers do use SSM parameter store. And of course, you're going to get the ECR images and you're going to send logs to Cloudwatch. So these two roles are very common, right? So we have created a task execution role here, which takes care of at least fetching the parameters and sending the logs and getting the images. So you don't have to think about, oh, what is this task execution role? What should I do? Now you would say, hey, I also need, for some reason, I also need to use secrets manager, let's say. So you can add secrets manager read-only policy here, and you can extend it as you need for your environment. This gives you a good starting point.
So it's really flexible. In other words, not only defined, but you can use it exactly to suit your needs.
Yeah,
exactly. And here is the cluster. ECS cluster is a pretty simple affair. There is nothing to install, nothing to upgrade, nothing like that. It's more of a logical grouping. And here we create the cluster with the name. In this case, we gave the name CFTC demo, right? Like in the other one that I created. And here is the settings for Cloudwatch. You can control how many days you want to retain the logs and things like that. So some of the sensible defaults already in here. And right now, the blueprints are only focused on Fargate. We are working on ECS EC2 blueprints as well. But here we define this is just specifying the capacity providers. There's actually a bug in the run task which requires you to have the capacity providers specifically called out. Again, like you don't have to stumble on it. We have stumbled it, and we have added, just declared the capacity providers Fargate and Fargate Spot. By default, it is putting everything on Fargate on demand, which we will see again how to change it when you launch your own service. So again, sensible things, right? Like tags are already there. The capacity providers are there. The logs is there. Cloudwatch Container Insights is simply a flag in this ECS module, and that flag is set to true. So you will get the basic free matrix out of ECS and Fargate in the Container Insights. So again, observability part is taken care of. And later on, you will see how the cost savings by using Fargate Spot comes in. So this is the cluster creation.
And that's all this is doing right now in the core infra. We're just creating the cluster. We haven't deployed anything. Yep. Okay.
Nothing. Just the cluster creation. And then here is the VPC. You can, again, like in many companies, there will be existing VPCs that you want to use. So you may just simply yank out this module and say, I am not in the business of creating VPCs. I will fetch the VPCs, and we will show you how we do that. You don't have to necessarily recreate VPCs for using ECS. You can fetch existing VPCs. You can fetch existing public and private subnets. But in this case, we are creating the VPCs. And look how simple some of these popular Terraform modules have made it, right? If anybody has set up these things from scratch, like the NAT gateways and IGWs and route tables, it's a bit of a learning curve and bit of a trial and error to set all these things right. Whereas here it's just a Boolean flag. Okay. And then here's again the retention policies for the Cloudwatch. You can change it to a month if you want. This like some sensible defaults in here. Lot of times customers also have used service discovery instead of explicit load balancer. So we have created some basic namespaces like a default. You can also have some system admin or some my app. Like you can have your own cloud map service discovery namespaces if you want. We only create one a default namespace along with the qualifiers of the cluster name and .local. So it's private DNS. Okay, this is for ECS service discovery. I'll show that as well in the example when you come to it. And this is the IAM role, execution role that you saw the list above for the SSM parameter and the CloudWatch and the ECR access. They are actually using a managed policy. It's so common that we have a managed policy for all of them. We are just creating the role and associating those policies. And that's it. That's your core infrastructure. And believe it or not, this is pretty much the core of many clusters, right? Like many users are using this exact same foundation.
So just to recap, all this particular Terraform template is doing right now is it's setting up your ECS cluster, it's setting up your VPC, and it's setting up your IAM roles. And then you're ready to go.
Exactly. So like this was pre-created from there, right? I fired off another one in US West 1. This is US West 2. This I have already created beforehand. So there is a ECS Blueprint infra cluster that I created. And there is a VPC by the same name as well. So if I go to VPC here, there is a VPC by the same name, ECS Blueprint infra, and this VPC has a bunch of private and public subnets, 6 of them, 3 private, 3 public. Okay. And there is the task execution role. So far, so good. All right. So we have created the foundation, and this is what most of the times you're going to start with to deploy your application.
We did get one question right now that I just saw pop up. Why such a complex logic for subnets? Why have 3 public and why have 3 private?
You can change it. Like this is roughly what we see in the pattern. Public, not so much actually. We could eliminate the public subnet. Most of the time it is one subnet per AZ is what we see, and mostly like 3 of them. No hard and fast rule to it. You can change it. It's up to your needs. You can just have, for example, only private subnets. You can have, but most likely you will have one subnet per AZ, at least one private subnet per AZ, just so that you distribute the task and get high availability.
I think,
and our best recommendation, of course, is to deploy in at least 3 availability zones to give you the maximum availability.
Exactly.
I think
they're available in the region.
I think from being a previous network engineer, they might be talking about our complex like subnet calculator built into what we have down there. So that certainly could be it. The reason we do that is to break apart the /16, but you can do that any way that you would like as well. It doesn't have to be as complicated as when you get to the subnets, but we did that for kind of like almost ease of use, where they, hey, input a CIDR and then we'll break it up for you. But you can easily do that a different way.
Well, and personally, I kind of like seeing that, okay, well, we do have something a little bit more complex, because a lot of times when you're showing demos, you just show things that are simple and you're like, well, wait, okay, this is simple.
Yeah.
Can I do complex things?
Yeah.
And instead, now we're working backwards. It's like, okay, here's complex. And if you can do complex, then you definitely can simplify it.
Yeah, exactly. I think there's a way where it's just like, yeah, we could just change the CIDR, but then there's another variable to change, the subnet mask. And then, instead of having like 4 different variables, you're going to input a global CIDR, and then it's going to break it apart for you.
Right.
So there were 2 questions and comments which came up. One of them is from RYUCS. Are the subnets automatically tagged for ELB discovery, like this does probably with the Terraform module for EKS?
Subnets automatically discovered by the ELB. We are explicitly providing it to the ALBs, but that's something which I can take note of to look into. Right?
Yeah, I would say the subnets are tagged, but ECS handles the kind of registration for the ALB in a little bit of a different way, which maybe we can show here as we demo the load balance service.
I'll take note.
And there was one more comment from Vlad, who is one of our container heroes. Thank you for joining us, Vlad, about the fact you can also, of course, only use public subnets if you choose in some way by removing the fact of NAT gateways and netting and a little bit of extra complexity. But of course, there are pluses and minuses for all these different kinds of considerations, and it will depend on your architecture specifically. The example we have provided here is also a private and public subnet.
Yeah.
One of my favorite answers to some of these questions. I mean, everyone has questions like, well, should I do this? Well, why are we doing that? And like, what's the best way to do it? And the answer I think I've heard now several times is kind of like, it depends. Like, we're showing you what's possible, but it's always, it depends. You can tweak it however you need. And that's that flexibility that everyone's talked about here today.
Yep. So we fired off just before we go into the deeper woods with the load balance service, right? I git cloned that repo. I went into the core infrastructure, and I have in my US REST one, I had done the Terraform apply, right? We didn't do anything crazy here. We changed the name in the TF vars and changed the region. And if you go in here in my VPC, if I change it to US West one, hopefully we have created a there is the CFTC demo that we just created. That's the name, and then there's the cluster in US West one. Okay. So here you go. It's just blank slate. You created the foundation. It has the execution role and everything all set up. And before I go into the load balance service, I'm going to fire off the load balance service here as well. This is what you would do if you follow the quick start guide. Is I'll go into the load balance service again, copy the Terraform examples to the Terraform, take a look at the TF vars, and change things, right?
It's a little bit more than what we had before, I assume.
Yeah, slightly more. Some of them are default, and this is more app specific, right? So there will be some more additional things. So we're gonna change some of these things. So our cluster is in US West one for sure. I'm gonna talk about this GitHub secret name in a bit. For now, let's go over here, and I'm gonna replace the repository owner. In this case, this repository belongs to AWS IA. And the core stack name was CFTC demo, right? So we are going to deploy it over there, CFTC-demo. And I'm going to give it a qualifier that this is a CFTC service name. I'm going to create a service discovery name in that namespace default. Maybe if we get time, we will also create the ECS demo Node.js application. I'll show that how it talks in the backend. And then there is the desired count. These are, again, settings that you can change if you want more than 3, less than 3, those kind of things. And I'm going to do one more thing here, and which is I'm going to add the capacity provider settings. This will also give you an idea of how to do flexibly some of the things that we have built into here, right? So what I'm going to do here is I will add a distribution for capacity provider. So what it does is I don't want to run everything in Fargate on demand because that's expensive. So I want to run little bit of my tasks in Fargate, and I want to run little bit on Fargate Spot. Okay. So what I will do is I will change the capacity provider strategy weight. Here is the capacity provider Fargate weight, right? And I'm going to make it 1. And I'll also change the capacity provider spot weight. So CP strategy underscore Fargate spot underscore weight.
And just while you're typing this, to make sure, so for those who aren't familiar with Terraform, because you've declared both of those CP underscore strategy underscore FG weight, because you've declared that and spot weight as variables, you're now referencing those variables and overwriting them in this file.
Yep.
Okay. Just making sure for anyone who's new so that they're following along.
Yeah. So what we did was we changed few variables from the from what we copied from the example that is already there in the repo. Change the repository owner, give it a new name and stuff like that. You can change more things. You can point it to your own repo, right? Like this is like it is pointing to my repo with this demo application, but you should experiment with your own app. That's the whole idea, right? Container port where the traffic is going to connect to the load receive from the load balancer. So that's what is here. And then I said I want to distribute between Fargate and Fargate Spot equally. That's what this means, and I'll show how it reflects. We'll skip the auto scaling part here, but there is also various types of auto scaling built in using CPU, memory, scheduled scaling. But for now, we'll skip that. Okay, so looks like we tuned our Terraform TFVARs. Hopefully, I didn't do any mistake. I'll fire that off or not. I have to initialize the. I have to initialize my module because this folder doesn't have any of that. Okay.
Arvind, I'm really impressed with your VI skills there.
Yeah, very much so.
I was thinking the same thing.
Yeah.
I'm an old guy.
You have a full containers from the couch talking about Vim.
All right, cool. Hopefully this will go. All right, while that goes and maybe succeeds or fails, we'll see. I'll switch back to my US West 2 region, and I'll talk about what is going on in that load balance service. The load balance service, by the way, how it looks is this is the front end. Many of you guys have seen this front end app from our containers from the couch, other workshop sessions, and the popular app that we use. So we defined the service. This is running in US West 2. I had pre-created this before the session. But this is the same service, ECS demo front end. And look at this capacity provider strategy, right? The same thing I did in the input variables just now. What it is saying is create the first 2 copies of the task in Fargate on demand. Fargate on demand, okay? After the first 2 tasks, the remaining task is split them evenly between Fargate and Fargate Spot. So here the desired count is 6. First 2 tasks will be in Fargate, and the remaining 4 will be split half and half. So 2 will go in Fargate and 2 will go in Fargate Spot. So there will be 4 tasks running in Fargate on demand and 2 tasks running in Fargate Spot. And since I know which ones they are, I can just directly click on that. So the UI doesn't tell you right away which one is Fargate Spot. So these guys are running on Fargate, right? And other ones, hopefully I can fish them out. Fargate Spot. Change it. Where are you, Fargate Spot? There you go. So there are 2 of them that are running in Fargate Spot, 4 of them that are running in Fargate. You can distribute. Now, the meta point I want to highlight is that, remember in the beginning, I promised that we want to give you end-to-end. So we want to give you cost savings also included as a part of it, right? We want to give you load balancers provisioned when you are doing this. And I'm going to show that in the code. So this load balance service has capacity providers set up for you. It has load balancer, target group, security group, all of those things set up and running. And if you have like an app team who is interested in knowing the result of it, you can use the Terraform outputs and give them things like the DNS name of the service. So that's the Terraform output. And here you can see that's the portal that got deployed, the load balance service. Okay. Now let's look at the code. What does this look to deploy a load balancer? It's going to be a little bit more involved. We're going to cover it in chunks. Again, the locals definition, tags, and stuff like that. And now look at the way we get the VPC and private subnets. Either we can use the ones that we have created from core infrastructure, right, with that core stack name, or you can give me some other tag, whatever you want, and I will fetch the VPCs and I will fetch the VPC private subnets and public subnets using the tags that you provide me. We are not going to recreate any VPC here because this is a load balance service definition, right? I've already created a cluster somewhere. This part focuses on creating the service and the task and deploying them.
Right.
Okay. So it will fetch the details. And the way we do it in Terraform is using the data construct. We give it the tag key. It gives me the VPC. I am essentially just fetching it from AWS, these values that were created before. Same for private subnet, same for the CIDR and all of those. Okay. Right. So I'm not recreating anything. This is like a shared cluster scenario. You're going to deploy many services. We're just fetching those things, including the task execution role, the service discovery namespace, or everything. I'm just fetching it from there. Right. Now, rest of it is about the service and the CI/CD and the part related to the specific app. So far, so good?
That sounds good.
Okay, cool. And now, if you guys have done things from scratch with respect to creating a load balance service, you know that there are a few steps that are involved. You have to create a load balancer service security group, right? So that the load balancer is able to receive the right traffic and send the right traffic. So that's doing over here. HTTP traffic all ingress to port 80. And then egress is the egress is going basically to the other side to your target endpoint. So it's all. Nothing wrong. You can again tune it and set it to either send it to just the private CIDR blocks, to set it only to public CIDR block. You can tune it however you want. But this gives you a good starting point for the security group for the ALB. Here's the ALB itself. Again, it requires a few things to be set up. In the ALB, like the gentleman earlier asked, like how do we discover the subnets? We are not discovering the subnets in this case. We are explicitly providing the subnets to the ALB. And this happens over here, right? So the ALB is running in the public subnet. It gets the public IDs, subnet IDs here. And then here is the listener port, in this case, port 80. Here's the target port. This is going to be that port 3000 that you saw on in the TFORs file. That's where the container is getting the traffic, right? And the health check. Really basic stuff right now. One thing which is missing as a best practice is to tune the deregistration delay. The deregistration delay is 5 minutes by default.
By default, yeah.
Probably a bit overkill. It makes your rolling deployment take a long time. So that is something which we will fix and add as a variable to set the deregistration delay. Okay, so those were the load balancer. Now I'm going to also do CI/CD, right? So again, going back to my promise that I want to deliver you an end-to-end solution, not just a run task type of experience. So this is going to create the ECR repository. Again, taking the container name and all of those. Here now, after this, we have details about the task and the service. So the task needs a security group as well, and the task is mainly going to talk to the ALB. So we allow it to talk to the ALB using the ALB security group over here on the port. Right. Yeah. Yep. Nothing crazy. If you walk through it, most of it is pretty straightforward. It's all put together is the main thing, right? Right. It's all put together for you to get started pretty fast, and then you can start fine tuning it for your app and stuff like that. For example, you may say, I don't want any egress for this app. It's got no business going anywhere, right? You can block it down. Is the service discovery. I'm registering the service to the default namespace. And here is the service definition. Most of it is, again, just assigning the variables. This is the part where we distributed between Fargate and Fargate spot. Is the cluster ID, right? The CFTC demo in the case that we created. Right. Load balancers and stuff like that. So you can see the details, and I was just playing with a bunch of auto scaling things. You can configure either scheduled scaling or via CPU, via memory, and things like that. And tags again, just so that you have cost visibility, which service is using what type of resources and how much they're costing. Okay. So far so good. I know
Yep.
it's quite a bit
So
of
far,
details,
yeah.
but again, these are pretty standard practice for a load balance service. It's a good starting point for you. Hopefully this guy is finished by now. The other one that we started, yeah. So now this particular service that we just created is another incarnation of the same one, right? So hopefully it is working. Oh, it's not working. That's also great.
Try to
We
reset.
love doing loving glass.
Oh
live.
yeah, it's
Yeah.
probably
Same
not
issue.
working because there is a CI/CD path associated with all of this. And let me show you that. And I promise that I will give you CI/CD and automation as well, right? So what we do here is, this is my US West 2. That one already works. Okay, so here is the ECS demo front end pipeline. Now, most of the time, the way customers use containers is their app teams will focus on their GitHub repository, their app GitHub repository, right? They will submit the code. The code will trigger the pipeline, which is what this is doing. It's listening for the ECS demo front end app repository. And then it will build the app. It will essentially build the container out of that. I'll show you what it uses. And then it will call ECS to deploy the service. Remember, we already created the service from Terraform. We created the service. We gave it everything that it needs. Now the CI/CD will fill in the detail about what image to use. Okay. So the CI/CD part that I've created here is picking the changes from the app repository, is building the image, and it's calling ECS to deploy that new image.
Okay.
Okay.
And it's all built in without having to kind of, I would say,
exactly
wire them together.
That's the part that I stopped over here. Rest of this module over here is exactly that. It takes code pipeline. It puts the artifacts in S3. That's what code pipeline uses. It uses encryption for those S3 buckets. It creates notifications to this topic as it goes through the various stages. And then here you will see the code build being used to build the image. Again, you don't have to use these things. If you use Jenkins, you can use that too. Nathan is working on generalizing this thing so that you can use different CI/CD pipelines. But this one uses code build. And here I give it all the details. Where is the repository? What should I be listening to, right? What task definition family should I use to change the container image? What is the container name for which I need to change the container image? So some of those details. What is the folder path where I will get the Docker file? Where is the build spec for it? All of those things are in there. Right. Okay, that's it. After this part, the code pipeline is this stitching of the stages. Listen for the source change, build it using code build, and then deploy using ECS. It's doing a rolling deployment. Okay. So now the reason why this guy is not ready, was not ready before it finished, is because the pipeline was building the image and triggering the ECS deployment. Okay. So we covered quite a bit of ground. Let me recap, right? So what you're going to do, most of you, if you are going to try this out, you are going to come and clone this repository, the Terraform Blueprints, and you're going to come to examples. You will have the core infra, and you will have a load balance service, at least to try with. You can also try the other ones like backend service and things like that. And you can get started pretty fast. Hopefully you can try it out with your app, and you can build the, as long as you have a Docker file, you should be able to build your own containers and use this as a starting point. You may have to fine tune some of the things, but it should be applicable there.
Yeah, one thing I wanted just to clarify is it looks like you should fork it, not clone it, especially if you're going to use these examples, because you're not going to have access to AWS IA to run the pipeline, right? It's not going to be able to.
You have to fork it.
Yeah. So just make sure that you fork this. If you have your examples as well from an application perspective, then feel free to point it towards your application repos for like a web app that you have.
Yep.
Right. And I think actually the instructions to fork that is listed there. And then you will also have to create a secret in your GitHub repository so that AWS can go and actually have access to the code to do, it has all the permissions and everything.
Exactly.
And there was one comment from Agile Guru that there's missing, for example, HTTPS support. So it could be that not everything's there at the moment. So two things I can ask firstly from you is, number one, raise an issue. It's an open source repository, so
Right.
we can track these. If you want to contribute a solution yourself, we'll review it. It works. We'd be happy to merge it into the repo. So thank you for bringing that to our attention, and thank you.
Exactly. So that GitHub token, again, we don't want you to put the sensitive things in TFRs or anything like that. That's why you'll, in the README, you'll see that it asks you to create the token and store it in Secrets Manager, and then just pass in the Secrets Manager name over the token name over here. You can also put it in SSM parameter store as a secure string, but anything rather than just plopping it in TFRs file here, right? So, and then this is the one that is used by Code Pipeline to be able to get access to that repository.
Yeah.
Okay, cool. So we have stitched together the logs and observability and all of this thing inside, and the CI/CD parts of it. We've created the load balancer needed and stuff like that. And nowadays, the one of the most common questions that we get is really around the cost. How can I optimize the cost? So we have prioritized a lot of that work, and you saw some of that in the support for Fargate and Fargate is bought. So I'm gonna pass it to Nathan to highlight some additional cost-saving mechanisms that we have already built, and maybe you can just get started on using some of those from the beginning itself, and be cost optimized from day one. All right, Nathan, I'll pause and I'll let you showcase those.
No worries. Thanks, Arvind. Let's kick this off. So we kind of focus cost around, one of the big ones is around VPC endpoints. This is kind of like a little known secret for customers that are running their containers on private subnets, where they may need access to S3, or they may need access to like ECR for the image pulls. And so we did have an example for VPC endpoints in here, which follows like a very similar path to what all of the examples follow. So tags are a common theme throughout this around, how do I tag everything that these blueprints are deploying in your environment. It's really easy to add additional ones, whether you want to add a project or environment or something that's relevant to your customers' environment as well. Very similar to the other example as well, we need VPCs for the VPC endpoints. So you could grab these this very similar way that we do in the load balance service or backend service as well. And then we do use the public module for VPC endpoints as well. So throughout the examples, you'll see that it's not, we try to not use custom built modules by us. We try to use the community-driven modules that are on Terraform registry that keep updating and contributions to as well. And here we see, some of the big ones would be S3, ECR. We have some other ones as well, just because some of these are like interlinked together. So if you're using ECR, you can have S3 as well. And this prevents, having your task not traverse the internet, right? So it just basically implements an endpoint, an ENI on each one of the subnets, which I'll show here in a second. But you can build VPC endpoints for a lot of different services. Cloudwatch is another big one, where it's just going to log locally to the local DNS name and then put your logs into Cloudwatch. This is also like a performance gain as well. It uses the AWS backbone. Again, it doesn't have to go out kind of the front door of the internet and use the public-facing endpoint. And then it tags all of them as well. Secrets Manager, Parameter Store are also in here. And then all of the VPC endpoints that are listed that are created via this module use 443. So that's why we surround this with a security group with 443 in here for all the private subnets. You can get very granular and use VPC endpoint policies to further, lock that down as well. But that really depends on, what application is talking to it. And so we kind of leave that up to the customer's interest around how they want to implement the endpoint policies.
Right.
Okay. So yeah, if we go in here, kind of show you what that looks like. If we go into the VPC homepage, you'll see I have two VPCs. One of them is deployed from core infra. And if you go down here into endpoints, you'll see all of those listed in here. And then you'll see each one of them for S3, Cloudwatch logs, the same ones that were listed inside of Terraform. And then this will create all of the DNS names as well. So just the DNS resolution will work locally for Route 53. And then that will change the DNS resolution for the task or the container to use that local endpoint versus the public endpoint for their respective service. And so we see a lot of cost savings as far as like the big ones would be S3, ECR, big one if you do a lot of deploys daily where you're fetching those images and pulling those images down from ECR, and then Cloudwatch logs. Okay. There is one caveat that I want to make so you don't shoot yourself in the foot, is that if you have VPC endpoints turned on, you have the ability to not use the NAT gateway. However, if you need to pull, let's say from public ECR endpoint, we don't have public ECR support. So all of the examples use a private repo in ECR. So all of the examples here will work within that and not having the NAT gateway turned on. So you won't even incur NAT gateway charges, which is another big benefit from a cost perspective.
And you don't have to create the VPC endpoints, from the get-go. You can create it later on whenever you want, but it's a good big chunk of cost savings. So might as well do it from the beginning itself.
Yeah.
Just
I just want to clarify, of course. Sorry, Jessica. There is, of course, a cost per VPC endpoint per month that you pay, but eventually it weighs out and becomes a good idea to do it because it will save you in the long run.
And just out of curiosity, going through these kind of blueprints, do we have cost estimates for like if we deploy out like the core infra and then the load balancer and then VPC endpoints? Do we have like a cost estimate of what it would cost somebody if they're using these samples?
I think our own repos might give a good. We do have it. We just haven't, I guess.
Just curious for anyone who wants to go try it out, like if they forget to delete anything or something, like, hey, on a monthly basis, we estimate this as you're learning, as you're getting started, will cost somewhere around this loose estimate. Just curious from like we were talking about cost savings, what does the cost kind of look like?
Yeah, we'll have to check on that one.
Okay.
It's like, I think few $100s. Our accounts are probably not a good representative because we keep running them and using them every day. But probably not more than few $100, hopefully, because Terraform Destroy does reliably destroy everything and delete everything most of the time. At least I haven't caught anything yet in these modules. So yeah, I think it shouldn't be probably not more than few hundred, I think.
Awesome.
And core infra, like, for ECS cluster, VPCs, that's going to incur very, very little cost if there's going to be nothing, deployed on top of them. But it's a good action that we've talked about in the past that we should take on and say, this is actually an estimate, like ballpark around what the examples will cost you.
I will add that.
Yeah. Really good call out. The other area that we really target here is something that AWS has talked about for a long time, ever since kind of the launch of Graviton and being able to kind of test this. And so we've gotten a lot of feedback around even like existing customers that are mature in maybe their Terraform and their pipelining capability, really like kind of this multi-architecture example where it's like, hey, how do I go about testing, building in ARM and building in AMD or x86 architecture and kind of test them out side by side, right? And so that's one of the examples that we built, which again comes with the CI/CD built in, and it's built a little differently because we have to build two images, one for ARM and one for x86. But we thought it was pretty neat around, how do we test these side by side? How do we do performance testing? Do they work functionally? And that's something that Arvind and I built as one of the patterns, because we just get a lot of questions around how do we get started? And again, this is a pretty simple way to get started here. You'll see this in the examples folder underneath Graviton. And, I'll just do a Terraform output here, which will, the output of this example is kind of that side-by-side stack standing up. One, you'll get a x86 for your ALB, which I can deploy here. And then you can kind of see around info. It's kind of a neat little app that you can see that it's running on x64 and Intel processors. And then the other one here, you'll see that it's running in an ARM architecture.
And this is the same Docker image, but as we say, built with a multi-architecture to enable both, regardless of you don't have to change anything in this case.
Yeah.
Well, in this case, that's correct. Yeah. So I think as we walk through this, hopefully you have the same experience, that you don't have to change anything and you can just get the benefit. That would be incredible. I hope you have the same experience. And so when we walk through the pipeline. You'll see that we just spin up, a code build instance for x86 with the Docker file. We point it towards the respective build specs, which are very similar in this regard, where it will just download the source. Again, it uses S3 as a backing for that for all of these stages here, and then I'll just skip down around, building the image. And then it pushes into that ECR repository that is also built, via Terraform.
Now, question, if somebody wanted to, let's say that somebody's not familiar with code build or code pipeline or any of AWS CI/CD, maybe they're a Jenkins user, maybe they're GitHub Actions. Is there a way that they can edit this template to maybe change the tasks that they want to go as part of their deployment? If they wanted to play around with how the Docker task is building or how the deployment step?
So right now it's pretty tightly coupled to the example. That's kind of what Arvind alluded to earlier around, hey, we need to decouple these from basically the application from the entire kind of infrastructure deployment piece. It wouldn't take too much for someone who's built Terraform in the past to not have it do the pipelining capabilities here, because as you saw in Arvind's example, all we do is just call those modules to build that out. This will get significantly easier in the future here, where we really want to have kind of separation of duties between the application CI and build process, like you said around, hey, if they want to use Jenkins, it should be a fairly straightforward lift to use Jenkins. And same thing with Azure DevOps around kind of like, hey, bring your own CI CD, and we can have Fargate and Fargate Spot be the landing zone for that.
Got it.
But it is quite simple around, kind of think of like code build as like a Jenkins worker, where it's going to spin up a worker, do a set of build instructions. You'll find all of the build instructions in the repo in what's called a buildspec.yaml, where it just outlines a set of instructions that you can see that are running here.
And that would be the equivalent to if somebody is a Jenkins user, that's equivalent to their Jenkins file.
Jenkins file, exactly. Yep.
Got it.
Something that would build that out. And I think correct me if I'm wrong, Jessica, but I think the Jenkins file even outlines the stages too, or it can.
Yes, you can. It can. It depends on how you've written it. Yes.
Yeah. So it's very similar thing. So our stages for all of the patterns are built in Terraform. And then we have that build spec, which is really kind of targeted toward the artifact of building the image.
Got it.
Yeah. So I had one question, which you say this is a cost saving, and specifically, why is that? Because we're running on what something called Graviton. Can you, maybe not everybody understands or knows what Graviton is. Can you give us just 1 or 2 seconds about what that actually means and why that saves our customers money?
Sure. Yeah, I'm certainly not a SME in the area, but we did launch our own type of chipsets that are called Graviton. We're actually kind of on that third iteration of that. So Graviton 3 recently came out as well. But Graviton is going to be just essentially it's a cheaper chipset. It does typically offer more performance. It's not necessarily guaranteed. So the long story short here is to test your application, because it depends on, your backend framework, whether it's Java or .NET. And so please test this out. But and again, that's the main reason for building this is like we can test them out side by side. You will get, what we've seen is what we advertise is 40% better price performance, kind of officially. But again, we encourage customers to try it out with their application specifically and see what your benefit is, right? Yeah.
Now, one of the cool things here, Nathan, maybe you want to highlight is we built 2 images, but the task definition, you only give one image link.
Yeah.
And you tell the operating system platform. So in the task definition, when you create those 2 services, you're not going to juggle 2 different task definition and images and stuff like that. The interaction between ECS and ECR relies on this manifest to resolve that for you.
Yeah, that's something that we added here. So after it builds both of the images, what we'll do is build a Docker manifest. And again, it's just another, basically stage that will, the output of this, if we scroll all the way down here, is this, right? So this is doing a Docker inspect on that manifest. And you can see that, we're building an ARM64 architecture, V8, and then x86 architecture here. And then
it's like an index on those 2 images. So when ECS calls ECR and says, I want that image for ARM as the operating system architecture, ECR knows that I'm going to go use that index and I will fetch you the right image so that you are not juggling in your task definition, and ECS agent is also not juggling anything. And it's pretty straightforward for you to test both of them in parallel.
Before we jump into this repo here and show you the manifest and the images, one thing I want to kind of highlight, because it might kind of trip people up, is that tag immutability is turned on. And so if you're trying to push an image into this repo with the same tag, it's not going to let you.
Right.
We tag all of the images in our examples with the git commit hash, which is a fairly common thing to do. And so as you're seeing that, and so if you're not doing a commit on your application repo and you're trying to run this pipeline again, you're going to run into a code build error where it's going to fail because it can't push an image that already exists.
And I think that is going back to somebody had asked earlier when at the top of the hour, as far as like if we're doing best practices, that is an industry best practice. You don't, especially in production, you don't want to be overwriting existing images. You want to be able to have anything that exists in your ECR. You want to be able to tag and correspond with a commit so you can see the changes that exist. So we are trying to make sure that you fall into success here.
Yeah, it's probably really important in this example because you probably are making application changes that you may or may not want to track around. Like, hey, if you're doing performance testing on ARM and you want to figure out like, hey, what was that version that we had there? It probably wouldn't be good to just type in V1, V2, V3. We can just make that an automated thing and part of the build spec process. So yeah,
I'm sorry to cut you off, Nathan, but we're kindly at the end of our hour, and I think we have another show coming on after us, so we don't want to take much of that time.
No worries. I'll just end here and just showing the manifest and the 2 images, that you can deploy, and then ECS service will just look at that CPU architecture and deploy those across the 2 architectures. So great.
That makes sense.
Thank you so much. It's awesome.
Thank you very much. I want to thank you all for joining us today. It was an amazing deep dive into the technology. And feel free to, as we say, the repository, we'll post it also on the show notes where you can find the repository for it on GitHub. If you please subscribe to our YouTube channel, containersfromthecouch.com. For more interesting content, we'll be back definitely within 2 weeks' time. And I want to thank everybody for joining us today. Thank you for joining us also on the chat. It was amazing. And everybody, have a great day.
Yeah. Thanks everyone.
So much, everyone.
Thanks, everyone.
Bye.